What's up, everybody? We're back. You know who it is. It's Dr. J. You know what I'm saying? Dr. J here. And let's just get into it. We're talking about hydrogen bonding. That's what we're talking about, hydrogen bonding today. So far, we've been covering intermolecular forces. We talked about London forces. We talked about dipole-dipole forces. We talked about ion dipole forces. And now let's cover hydrogen bonding, right? Hydrogen bonding forces. So, key thing is that hydrogen bonding, right, as it sounds, is going to evolve hydrogen. So it will evolve hydrogen. Okay, so that's a key hint. You know you got hydrogen bonding. Why? Hydrogen. All right, so you don't see a hydrogen, chances are it's not hydrogen bonding occurring. Another thing, so here's another thing about it though. And this is a big one as far as with hydrogen bonding. Hydrogen bonding, right? We're only going to see bound to very electron negative atoms. Okay, so it really should be bound to oxygen, nitrogen, and fluorine. That's it. Okay, NOF. All right, I like to think of it as NOF. Right, because if we look at my periodic table, imagine that it's going to be nitrogen, oxygen, and fluorine. NOF. So if you got a hydrogen bond to nitrogen, oxygen, and fluorine, you have hydrogen bonding occurring. Okay. Now, what's so important about hydrogen bonding is that hydrogen bonding is actually the strongest intermolecular force of them all, okay, besides ion dipole. Okay, ion dipole is actually the strongest one. But hydrogen bonding, if you're not including ion dipoles, okay, this is the strongest one. And this is because of that hydrogen. That hydrogen is a key player as far as why this is a strong intermolecular bond. Okay. So, because hydrogen is so small, right? We got a small hydrogen atom here. When it goes to bond to these electron negative atoms, right? Oxygen, nitrogen, fluorine, we're going to see that they like to take away that electron from hydrogen, right? Because, they're so electron negative, they need those electrons, right? They like to eat those. So they're going to take away those electrons from my hydrogen. And once again, hydrogen only got one electron. So if you take that away, they don't have any more electrons, right? They don't have any more. So, right, when that electron is getting pulled away towards my very, 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 very electron negative atom, okay, this is where we're going to see, right, for that hydrogen atom, the nucleus become deshielded, okay? So it's going to become deshielded. So basically, when this happens, this is where my hydrogen, okay, gets this strong positive charge. There's no electrons around it, right? So no electrons around it. It don't got nothing left to do but be positive, right? We can't be negative. Oh. All right, so it's going to be a positive charge. The hydrogen would be positive. So because it's now just a positive charge, guess what's going to start happening? That hydrogen is going to start attracting, what it's about to start attracting, those negative partial ends, right? Just like all of the other intermolecular forces we talked about. There's attraction with these molecules because of this partial positive and partial negative ends. Okay. So because hydrogen is so positive, it's definitely going to start to attract those negative ends. So for example, right, this is what we're thinking of with hydrogen bonding, right? We got our hydrogen here bound to, it could be any one of the three, nitrogen, oxygen, or fluorine. Let's just, for instance, say it's oxygen, okay? So our hydrogen is partial positive, and our oxygen, going to be a negative charge, right? Very electron negative. We're bringing those electrons toward us, okay? And what we're going to see here is that we got our moment happening here. So our negative end will be attracted to the other molecule, our positive end. And when we start to see these attractions, right, this is where our hydrogen bond will start to form, right? Intermolecular forces, right? Intermolecular forces. And once again, it makes sense, right? Intermolecular, bounds within the molecules within that same compound, so they're interacting. And this is once again how we're getting our say some matter, etc., as I mentioned before in the other video. So our negative end is being attracted to our positive end here. And this is where we start to see that attraction form, our hydrogen bonding, right? And if we look on the other end, right, negative, partial negative end, the oxygen, bound to our hydrogen, okay? So one thing about hydrogen bonding, right, since we have this small hydrogen atom, we're going to see that they're actually going to be closer together, right? Because they're closer together, it's a stronger attraction, okay, with those molecules close by each other. So this stronger attraction, right, we got a stronger bond, okay. So this is why we see this is why hydrogen bonding has these strong bonds, right? Because one, hydrogen bonding totally deshielded, no electrons around it, but also hydrogen is a small atom, so they're able to get closer in to each other.